Hello everyone. Hello.
Yes, sir.
Yes, sir.
Yes, sir.
So in last lecture we had discussed directivity and antenna efficiency. Okay. Now today we are going to discuss next point, that is gain of the antenna. Okay. Before going to the gain of the antenna, all of you must be know that what is the directivity. What is the directivity? Because your gain of the antennas are totally depends on the directivity, or simply it can be say that your gain is related to the directivity. When directivity is understand clearly, at that time gain should be understand perfectly. Now, what is the directivity? Directivity is the ratio of antenna radiation intensities. That is, antenna radiation intensity to the isotropic intensity of that particular antenna. Is that clear? Gain is directivity is the ratio of radiation
Intensity averaged overall in direction.
radiation intensity in a particular direction to the isotropic radiation intensity of that particular antenna. So this is the directivity of the antenna. Now, today we are going to discuss the gain. In earlier days, this gain or this directivity has not separate discussion. It is considered as like a same terms. That is directivity gain. Okay. So at the earlier, when antenna is designed, manufactured, when it is taken to the discussion, at that time there was a concept that is directivity gain, and this is your directivity. Hello.
Yes, sir.
Now next point is the gain. Now gain is the totally related to the directivity. Is that clear? Gain is totally related to the directivity. And now, so there are two different concepts for the gain. First one concept is only gain, and second one concept which is related to the gain is known as relative gain. Is known as relative gain. So we are going to discuss two different concepts, that is gain and directivity, gain and relative gain. Now when gain is calculated, at that time your directivity can be takes into account the efficiency of the antenna, also now. Now efficiency of the antenna is equal to E0 into EC into ED into E what?
ER.
R.
ER.
E ER. What is the R? What is the R?
Reflection. Reflection.
Reflection efficiency. R is the reflection efficiency. And C is your
Conduction.
Conduction efficiency.
conduction efficiency. And D is your direct dielectric efficiency of that particular antenna which had taken by us. Now, this conduction and dielectric efficiency combinedly called as radiation efficiency of that antenna. Okay, and your total efficiency of antenna can be calculated by using radiation efficiency and reflection efficiency. Is that clear?
Yes,
Am I
sir.
audible?
Yes.
Yes. Now your gain is totally related to directivity and efficiency of the antenna. Is that clear? So before going to the gain, all of you must be know that what is the directivity and what is the efficiency. Efficiency of antenna is the product of different efficiencies like conduction efficiency, reflection efficiency, and dielectric efficiency. And your directivity is the ratio of radiation intensity of antenna in a particular direction to the isotropic radiation intensity of that or of same antenna. So by using these two terms, by using these two parameter, we can derive next parameter. Sorry, we can derive next parameter, that is gain. So now what is the exactly gain? So you know that the simple term gain. What is the gain, Dikshit? What is the gain? In your simple antenna, or in your simple electronic circuit, how can be gain will be calculated?
Output
Yes,
voltage किंवा current divided by input voltage किंवा current.
output voltage divided by output current. Sorry, input current, or output current divided by input current. It is the gain of the, that is voltage gain or current gain, calculated by using that equation, especially in any electronic circuits. Okay, is there any doubt in the derivation of the gain? Yes.
No,
If
sir.
you know that, then we can proceed further. Now, what is the gain? Now we are going to calculate the derivation, or we can going to derive the derivation for the gain of antenna now instead of electronic circuit. The gain calculation in electronic circuit is so easy. It can be calculated by using simple two terms, that is output and output voltage or currents. Okay. But now we are calculating the gain of the antenna. Okay. Before going to calculate the gain of the antenna, we must be know that what are the different parameters of the antenna. There are number of parameters of antenna, in which we had discussed different parameters, in which especially radiation patterns, then lobes, then beam width, then beam area, then directivity, then efficiency, then radiation intensity, radiation density, radiation power. These are the all parameters of the antenna. And now your gain is the next parameter of that antenna. And we should be calculate this gain by using directivity. It is totally related to the directivity. So gain of antenna in given direction. Gain of antenna in given direction. So student, listen carefully. A single antenna can be, it has number of different gain. Gain will be different when direction of radiation is changed. That means with respect to the number of directions of the radiation of the antenna, that means there are number of gains. So direction should be must. So gain of the antenna in a given direction is defined as, it is defined as, listen carefully, it is defined as, listen carefully, the ratio, once again, the ratio of intensity, ratio of intensity. Mala, once again, it is the ratio of intensity. Your directivity is also ratio of intensity, but it is radiation intensity to the isotropic radiation intensity. But in the gain, there is slight difference as compared to the directivity. Now here is the ratio of the intensity in given direction in given direction to the, to the radiation intensity that would be obtained if the power accepted by the antenna were radiated isotropically. Were radiated isotropically. Got it? समजतंय का?
Yes, sir.
समजतंय का? काय सांगितलं? Ratio of intensity in given direction. Ratio of intensity in given direction to, first concept is understand. Ratio of intensity. Ratio of, intensity in given direction. Okay. To the radiation intensity, instead of isotropic radiation intensity, we are taking radiation intensity that where radiation intensity, but कुठली radiation intensity, in that radiation intensity power accepted by this direction is isotropically. That clear? Power accepted by the antenna were radiated isotropically. म्हणजे ज्या अँटेनाची पॉवर आयसोट्रोपिकली रेडिएट होती, म्हणजे intensity is given in direction, it is clear that it is same as like directivity, but here is the radiation intensity of antenna that where power accepted by the antenna where it will be radiated and isotropically. म्हणजे एक अँटेना आहे, हा काय करतो, एका पर्टिक्युलर डायरेक्शन मध्ये काय करतोय, रेडिएशन इंटेन्सिटी रेडिएट करतोय, समथिंग रेडिएशन्स आहेत इन अ गिवन डायरेक्शन. मग हे कन्सिडर करायचं न्यूमरेटरला, मग डिनोमिनेटरला काय कन्सिडर करायचं आहे, रेडिएशन इंटेन्सिटी कन्सिडर करायची परत एकदा, पण कुठली, दॅट वुड बी ऑब्टेन्ड इफ पॉवर, काय म्हणतोय मी, that would be accepted if power, that is P, if power accepted, that means accepted power means P in, accepted power of that antenna where radiated isotropically. म्हणजे जेवढी काय पॉवर ह्या अँटेनाला मिळती तो अँटेना काय करतो, इन इक्वल अमाउंट मध्ये ऑल डायरेक्शन मध्ये ही पॉवर काय करतो, रेडिएट करतो. म्हणजे तुमची आउटपुट रेडिएशन पॉवर काय झाली, P in divided by 4 pi. 4 pi means this 360 degree and this is 360 degree, means your 4 pi. So your total isotropic radiation of that antenna is equal to in, इकडचं दिसतंय?
हो सर.
Yes. So काय म्हटलंय? Intensity in given direction. It can be easily understand. But what is the next point? The power accepted by the antenna were radiate isotropically. म्हणजे माझ्याकडे आज जेवढी एनर्जी मिळाली मला माझ्या जेवणातून वगैरे तेवढी एनर्जी मी इक्वल अमाउंट मध्ये काय करतोय? डिस्ट्रीब्यूट करतोय इन ऑल डायरेक्शन. समजतंय? म्हणजेच काय थोडक्यात मी आता इथं उभा आहे सेंटरला आणि मला सूर्यप्रकाश मिळतोय थोडक्यात इन दॅट इज इनपुट पॉवर माय and that power is P in. Suppose I am an antenna and direction of radiation is my front head. So this is first point, that is radiation intensity in a particular direction. To the radiation intensity, to the म्हणजे काय आता परत दुसरी रेडिएशन इंटेन्सिटी, पण कुठली रेडिएशन इंटेन्सिटी आहे? टू द रेडिएशन इंटेन्सिटी दॅट वुड, म्हणजे जी रेडिएशन इंटेन्सिटी काय आहे? इट विल बी इफ at that time power accepted by antenna is radiated isotropically in all direction in equal amount. That power will be calculated by using P in, that is input power will be radiated isotropic. मतलब कि क्या है? Each and every time we are taking 4 pi because a circle has 360 degree angle, or again another circle has 360, that is 2 pi. Is that clear? 180 degree, another 180 degree, and now this is not a circle, this is a cube, this is a, for example, a ball, a solid angle. So we are taking 4 pi for the solid, and we are calculating a angle for the solid material, that is radians. Okay. So this power is equal to P in divided by 4 pi. Now, हे समजतंय का? Intensity in given direction to the radiation intensity that would be obtained if power accepted by the antenna were radiated isotropically. Now the radiation intensity corresponding to the isotropically radiated power. Hello. Please mute your mics. Mute your mics. Now, the radiation intensity, listen carefully, the radiation intensity corresponding to isotropic radiated power is equal to the, that is radiation intensity. Radiation intensity. This radiation intensity is equal to the कशासाठी असणार आहे? corresponding to the isotropically radiated power is equal to the power accepted by the antenna is equal to the power accepted by the antenna divided by 4 pi, divided by from 4 pi. And for the gain we can derive, we can write a mathematical equation by this definition of antenna. Can we suggest how can we write the definition, or how can we write mathematical equation for the gain by using your definition? Is it clear? Got it? What is the gain? Yes? You got it? What is the gain?
Yes, sir.
Yes. Now your gain of the antenna in a given direction is defined as the ratio of the intensity in a given direction to the intensity, that is radiation intensity, that would be obtained if the power accepted by the antenna were radiated isotropically. Now the radiation intensity corresponding to the isotropically radiated power is equal to the power accepted by the antenna to the 4 pi, and it can be write down by using this equation. Now we can write a equation for the gain, and that equation can be write down by using intensity in given direction. Intensity means we are calculated, that is intensity is equal to U. Now this u can be written down by using theta and phi, that is different dimension or different components of that particular intensity, that is theta comma phi, that is your radiation intensity divided by radiation intensity corresponding to the isotropically radiated power in equal amount by the accepted power, and this can be written down by using equation P in divided by 4 pi. So this is the equation number 1 for the gain of the antenna. Is that clear? How can we get this equation? Is that clear? Yes?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes. So this is got it by all of you. So how can we solve this equation once again? So this equation can be rewrite by using that its gain is equal to this 4 pi can be x here. Instead of denominator, we can take numerator. Okay. So 4 pi into u into theta comma phi. Now theta and phi are the two different components of your radiation intensity. Is that clear? And divided by P. This is your equation number 2. And there is no unit for the gain because this is your gain. Your intensity has some unit. But when we are calculating the gain, at that time two different units can be cancelled to each other and your gain parameter is dimensionless. There is no dimension. Now, in most of the cases, we deals with the relative gain instead of simple gain. We deals with relative gain instead of simple gain. Now, how can we calculate? आता कोणीतरी आले, किती उशिरा येत आहे? Okay. Now, in most of the cases, we deals with the relative gain instead of this simple gain. Now, there are two different gains. One is simple gain, another one is relative gain. At that time, relative gain can be defined as, see carefully, relative gain can be defined as the ratio of the power gain. See carefully, relative gain, that is relative gain, can be defined by using the ratio of the power gain in a given direction to the power gain of reference antenna. Is that clear? Suppose we have a dipole antenna or we are calculating the power gain of the dipole antenna. At that same time, the power gain of the dipole antenna divided by the power gain of the reference antenna. That means dipole antenna is compared with the another reference antenna. That means suppose we are measuring the height of the two different persons or three different persons. जसं की आपण compare करतो एकमेकांना तसं इथं for the comparison we are taking a reference antenna. We are taking a reference initial antenna for the readings. And for that reading we are calculating the relative gain. Now relative gain is the ratio of the power gain in the given direction of antenna to the power gain of a reference antenna in its referred direction. In its reference direction. Suppose मी एक antenna आहे, मी पॉवर रेडिएट केली, दुसरा एक अँटेनाला कन्सिडर केले, त्यांनी रेफर केलेल्या अँटेनाला काय करायचं, त्याचा गेन घ्यायचा आणि त्याचा काय करायचा, रेशो घ्यायचा. नाउ दिस रेफरन्स अँटेना इज युजुअली a dipole antenna, horn antenna or any other antennas. See, this may be objective in your test. The reference antenna is usually a dipole antenna, horn antenna or any other antennas whose gain can be calculated or it is known already. So this may be your objective. Dash antennas are known as reference antennas, or dash antennas can be used as a reference antennas for the calculation of the gain of different antennas or for the calculation of the relative gain of the different antennas. Now in most cases, however, reference antenna is lossless isotropic antennas. In most of the cases, reference antennas is known as lossless isotropic sources. Now at that time, the relative gain can be calculated by using equation that is G is equal to that 4 pi into U into theta comma phi into theta comma phi divided by P in. But instead of a simple antenna, this P in is derived for the lossless isotropic antenna. Instead of antenna, we can write down lossless isotropic source. Once again, it is dimensionless. When the direction is not stated in that particular isotropic antenna, at that time we can take power gain in usually direction of maximum radiation. ज्यावेळेस डायरेक्शन डिफाइन केलेली नसती त्यावेळेस पॉवर कुठली घ्यायची तर जिथं मॅक्झिमम रेडिएशन आहे सिग्नलचा बाय अँटेना ती डायरेक्शन घ्यायची. इज दॅट क्लिअर?
Yes, sir.
यस. कोणाला काही डाऊट आहे का?
No, sir.
No, sir.
No doubt. Okay. Okay. Now we have to discuss antenna efficiency. Is that clear? Now by using antenna efficiency, again we can rewrite the total radiated power. बघा, total radiated power म्हणजे काय असते? Input power गुणिले radiated power now. म्हणजेच काय असणार आहे? Input power is equal to P radian divided by your dielectric and conduction efficiency. म्हणजेच त्याचं काय झालं तिथं कम्पेअर केलं and after that we can define the equation for the P radian, that is P radian is equal to P in into ECD into ECD. That means by using this equation we can calculate the total radiated power. We can calculate the total radiated power, where we know that what is the ECD, where we know that ECD is the antenna radiation efficiency. Antenna radiation efficiency, where there are combination of two different efficiencies, that is conduction and dielectric efficiency, and combined it is called as antenna radiation efficiency. Is that clear?
Yes.
If you have any doubt till now, you can ask. Okay.
हॅलो.
Yes.
हा गेन पॉइंट कोणीकडे आहे तुम्ही दिलेल्या पीडीएफ मध्ये?
गेन, अरे तुम्ही हा प्रश्न नाहीये, हा नंतर विचार. कुठं आहे, काय आहे, लक्षात आलं का? If you have any query related to the concept gain, you can ask to free. You can freely ask. But where is this? You can search it. Okay. Yes. In your textbook, it will be present or it will be get on page number something 60 to 70. Is that clear? Is that clear? 60 to 70 page. In between 60 to 70, it may be 66 or 65 page number. Is that clear? Now,
हॅलो
your is
हॅलो
yes.
तर पी इन म्हणजे लॉसलेस आयसोट्रोपिक सोर्स आणि पी आउट म्हणजे
Prashant, P in is not lossless isotropic source. P in is the input power of that lossless isotropic power. P in is not equal to lossless isotropic source. Lossless isotropic source is the medium is the antenna, is the referred antenna, and that power is taken for that lossless isotropic source. This is the power of the lossless isotropic source. These are the not same term. Power is totally different than lossless isotropic source. Is that clear? Power is taken by the lossless isotropic source. Power is not lossless isotropic source. Is that clear? Yes, Prashant?
हो सर हो.
Yes, got it. Now, according to the IEEE standards, what is the IEEE? Yes, you know that what is the IEEE?
Indian
Multiple
Institute,
time. Yes, international.
electrical and electronics.
Yes,
असं काहीतरी आहे.
electrical and electronics engineering. Institute of Electric and Electronic Engineering, and that institute standards says that, or according to IEEE standard, gain does not include lossless arising from the impedance mismatch. Now, what is the impedance mismatch? Impedance mismatch means your reflection losses. That is, reflection losses is also called as reflection efficiency of that particular antenna, and polarization mismatch. Polarization mismatch means your ECD. Is that clear? Now, according to the IEEE standard, gain does not include losses. म्हणजे जो गेन असतो त्याच्यामध्ये कुठल्याही प्रकारचा लॉस इन्क्लूड होत नाही. बरोबर आहे? लॉस हा लॉस असतो. लॉस doesn't consider into the gain. So your gain does not includes into the losses arising from the impedance mismatch and arising from the polarization mismatch. Is that clear? Now,
Yes, sir.
at that time we are considering two different gains. One is simple gain, that is G, and other gain is referred to as ABS. Now ABS is, what is ABS? Is absolute gain. ABS is absolute gain, and it can be written by using GABS. That is absolute gain. That also takes into the account that the reflection and mismatch losses represented. जर gain मध्ये हे losses consider नाही केले, it will be considered into your absolute losses. That means your reflection and your polarization mismatch losses represented in that equations can be taken into that particular equation, and we can write an equation for that gain by using this equation. This can be rewrite. 1 second. Now, this absolute gain can be rewrite by using simple G instead of simple G. We can write this G in bracket theta comma phi. It can be written down by using equation, that is ECD, your radiation efficiency, that is ECD. Now ECD into 4 pi, ECD into 4 pi into U into theta comma phi divided by your P radian now. Divided by P radian. I had right now here P radian is equal to P in into ECD. Okay, is that clear? Is that clear? Before that,
Yes, sir.
there was an equation that is G is equal to 4 pi into U into theta comma phi divided by P. Your earlier equation. Is that clear? Now we are moving toward the absolute gain from simple gain. At that time, I am saying that your radiation and mismatch gain can be considered into the calculation of the gain, but it will be considered into the absolute gain. At that time, we know that the equation that is P radian is equal to P in into ECD. Now, when we take mismatch gain, at that time we should be write down P radian. Now, instead of P in, we can write P radian to this position. But when we write down P radian, at that time we are taking into ECD, that is gain is considered in that radiation. Not only radiation, not only input radiation, but radiation is considered your losses, that is radiation losses, mismatch losses. And by using this equation, we can write P radian to the denominator of that particular equation. But when we write P radian, at that time we are taking ECD, so also we are taking at the numerator, that is ECD. हे समजलं कसं आलं ECD? P in म्हणजेच काय असतं? P radian is equal to P in into ECD. मग हे ECD आपण एक्स्ट्राच घेतलंय. मग एक्स्ट्राचं जे इथे घेतलं तर इथे घ्यायचं एक्स्ट्राचा. म्हणजे न्यूमरेटरला जर घेतलं ECD तर डिनोमिनेटरला घेऊ शकतो आपण. म्हणजे they will be cancelled to each other. Okay. Now this is your absolute gain. Now, what is the exact difference between gain and absolute gain? In gain, we have not considered the mismatch losses or radiation losses, but in the absolute gain, we are considering the mismatch losses and radiation losses. Now, this equation is totally related to the directivity equations. Now, you know that the directivity equations, your directivity equations has derived into that last particular lectures. Now this equation can be derived by using G theta into phi is equal to this your ECD into 4 pi U into theta comma phi divided by P radian, and this is the your directivity of antenna in a particular direction. So your gain is relative to the directivity. So by using directivity, by multiplying simple radiation efficiency, we can calculate the gain. That means product of radiation efficiency and directivity is known as the gain, that is absolute gain of that antenna. So once again, this is your absolute gain. Now, when there is no given direction is present, at that time, we can calculate the maximum value of the gain is related to the maximum directivity. This is simple directivity. But when we are taking maximum directivity of the antenna, at that time we can calculate the maximum gain of that particular antenna, and it can be calculated, it can be derived, it can be defined by using simple G0, and it can be written down by using G theta comma phi, and we can use maximum gain, and it can be defined by using simple ECD into D in a bracket theta comma phi. Once again bracket is completed, and this directivity should be maximum, and it can be once again write down by using equation, that is G0 is equal to ECD into D0. What is G0 is equal to ECD into D0. So this is your maximum gain when maximum directivity is considered. This is your absolute gain when absolute directivity is considered with this product. That means absolute directivity can be calculated by using simple by multiplying by radiation efficiency to the directivity. It can be calculated. So these are the different equations related to the gain. आणखी काय कोणाला अडचण आहे का याच्यामध्ये? Yes, if you have any doubt, then you can ask. Yes. कोणाला काय problem? Hello.
No, sir.
No problem. Now once again your absolute gain, that is absolute gain, can be calculated by using. You know that what is the ER? Yes, you know that what is the ER? That is your absolute gain can be calculated by using ER, that is reflection losses. Here we consider the radiation losses. Is that clear? Now we can derive equation for the reflection losses. Now reflection losses into directivity, that is theta comma phi. Okay. Now you know that the reflective equation for the ER as the 1 minus the power E.
Tau.
Tau, yes, it is tau, but what is exactly tau?
Voltage reflection
It
coefficient.
is voltage reflection coefficient of the antenna, and it can be write down instead of ER. Now 1 minus tau square into D into theta comma phi. Now this can be also rewrite by using equation. What equation? Your 1 minus tau square into G. Sorry, instead of D, there is G, not D. When we calculating the absolute gain, but we know that the G theta into G theta. This equation. Now once again, above equation can be rewrite by using ER into ECD into D into theta comma phi, and your final equation may be rewrite by using that is efficiency, that is total efficiency into the directivity of that antenna, and your final equation will be antenna efficiency into directivity of the antenna in given direction, and it is known as your absolute gain equation. That means when we are move toward the gain to absolute gain, at that time we are considering the mismatch losses and radiation losses or reflection losses. First we derive the two different equations by using reflection losses and radiation losses, and it will be combined finally together, and we have get equation that is absolute gain of antenna is equal to the total antenna efficiency into the directivity of that particular antenna in a given direction. So this is the derivation for the gain, that is antenna gain and absolute gain. Now if you have any query related to that particular antenna gain and absolute gain, we are free to ask some questions related to the antenna gain. Yes, please. Yes. This is absolute gain. Also, we can calculate the maximum absolute gain. Instead of GABS, we can write down only G0 ABS. That means this 0 is notation specially used for the maximum gain. And instead of D theta comma phi, we can write simply E0 into D0. That is your G0 ABS is equal to E0 into D0. So this is the equations related to the antenna. and your G0 can be calculated by using G theta plus G phi. That is your gain, that is maximum gain, has two different partial gains, that is G theta and G phi, or by using two different components we have two different gains, that is known as partial gains, and they are G theta and G phi. And your G theta and G phi can be expressed by using 4 pi into U theta divided by P in. That means your radiation intensity divided by the total radiation in, that is total isotropic radiations. This same definition is present for every gain, but when we are taking gain, absolute gain, or partial gain theta and phi, at that time we are taking simply a same direction for that calculation. लक्षात येतंय, ज्या डायरेक्शन मधलं गेन तुम्ही कॅल्क्युलेट करणार आहे त्या डायरेक्शन मधले रेडिएशन्स कन्सिडर करायचे आणि त्याला डिवाइड कशाने करायचं, टोटल आयसोट्रोपिक रेडिएशन्स. सिंपल कन्सेप्ट आहे. इज देयर एनी क्वेरी रिलेटेड टू द गेन कन्सेप्ट? यस,
नो सर.
हे दिसतं का सगळं लिहिलेलं बोर्ड वरती?
येस
Yes, sir.
इफ एनी डाऊट देन
No, sir.
यू कॅन आस्क. आणि कोणीही लिव्ह करू नका, मला एक स्क्रीनशॉट घ्यायचा आहे. आणि नेक्स्ट लेक्चर विल बी स्टार्ट विदिन 2 or 3 minutes.